Today we're going to start learning about systems of linear equations and how to solve them. Throughout this whole chapter, we are going to solve and learn 3 ways to solve these guys. So eventually you guys will be able to choose what way you want to solve the systems, which is pretty cool. Now let's talk about what a system of linear equations is. A system is 2 or more of something. So a system of machinery is 2 or more different machines put together. So a system of linear equations is just that. It is 2 or more linear equations. So you guys will see problems that have 2 or more, which in just this chapter we'll just have 2 linear equations that we're going to solve. So a solution is going to be the coordinate that the 2 lines cross. So it's the coordinate the 2 lines intersect each other. So we're going to find out mathematically in 3 different ways where these lines are going to intersect and cross. And that one point where they cross is going to be your answer. So we're first going to solve by graphing. This is pretty simple. You're just going to graph the 2 lines in the same coordinate grid. Then you're going to find the point they cross, and then you can plug in your answer to check your work, because we love that we can check our work in math to know that you're right. So let me go ahead and organize this so you guys can see it. So that's what we're going to do. We're going to graph 2 lines in the same coordinate grid, find that point where the lines cross each other, and then we can plug in our answer to make sure that the answers are correct, so you don't have to guess to see if your answers are correct. So we're going to get right into some examples. Right here, I have 2 examples we're going to work on. So this first one, they're both in slope-intercept form. We're going to graph both of the lines in the same coordinate grid. So the first point I'm going to do in purple so you guys can see it pretty clearly. We have that my y-intercept is at positive 5. So I'm going to go up to 5 and put my point. And then I have that my slope is 2. So that means I'm going to go up 2. I'm going to go up 2 over 1. Okay, so we've done this many, many times in class. You go up 2 over 1, up 2 over 1. Now I ran out of space. So that means I'm going to continue my line by going down 2 to the left 1, down 2 to the left 1. Now, for a system of linear equations, it's kind of important to put a bunch of dots and to have an incredibly straight line. So if you need to use a ruler, please do so, because we need to be very exact in our answers. So that's our first point, or our first line. Now I'm going to do the second one in orange. So our y-intercept is at -1. So I'm going to put my point there. My slope is -4. So if I do -4 over 1, that means I go down 4 to the right 1. So if I go down 4 to the right 1, I can do that a couple times, but then I lose my spots. Like I need to go the opposite direction. So now I'm going to go up 4 to the left 1, and you see that we have actually figured out what points the 2 lines cross at. So we just graphed our lines, but this is going to be the most important part. That is the point the 2 lines cross. The coordinate is -1, positive 3. And that's going to be our answer. Now we have to check to make sure they're correct. So we're going to plug in -1 for x and 3 in for y on both equations. If it's correct or they're equal, then we know we're right. So in the first equation, I'm going to do this back in purple. We have y is 3 equals 2 times x, which is 2 times -1, plus 5. So we got to make sure that that is true and equal. So 2 times -1 is -2. So I'm going to rewrite all of this to be -2 plus 5. -2 plus 5 is the same thing as 5 minus 2, which is 3. So we have that 3 equals 3. So we know it's correct with this first equation. Now we're going to try it with the second. The point has to work with both equations for the answer to be right. So now we have, instead of y equals -4x minus 1, we have 3 equals -4 times our x, which is -1, minus 1. So negative 4 times negative 1, two negatives cancel out to create a positive 4 minus 1. Oops. And now 4 minus 1 is 3. So we have, again, 3 equals 3. So because both of these equations work with this point, we know that this is the correct point and this is our answer. All of your answers for this entire chapter are going to be a coordinate, guys. You need to label it with parentheses, comma, all of that. So that's what you got. Let's move on to the second example. So I'm going to graph the first one in purple. My y-intercept is at negative 1, so I'm going to go to negative 1. And my slope is 1, which means I go up 1 over 1, up 1 over 1. Okay, so do as many dots as you can to make it as accurate as possible. I'm also going to do some going down, where I go down to the left 1, just so that I have enough points that I can clearly see where the lines are crossing. The second equation I'm going to do again in orange. My y-intercept is at positive 3, and my slope is negative 1. So to do negative 1, I go down 1 to the right 1. Down 1 to the right 1. So I see, the lines are crossing, which is fabulous. So I see this point that they're crossing at, so I'm going to write it, which is 2, 1. And remember, 2 is our x value and 1 is our y. So we're going to plug those into the equations to double check that they're correct. So this first equation, I have my y, which is 1, equals x minus 1. Well, our x is 2 minus 1. Well, 2 minus 1 is 1. So we have 1 equals 1. It works with our first example. Now let's try it with the orange equation, the second equation. We have our y, which is now 1, equals negative x plus 3. So 2 is x, so we're going to have the negative x, so it's negative 2 plus 3. So negative 2 plus 3 is the same thing as 3 minus 2, which is 1. So we get 1 equals 1. It's correct. We know our answer right here is correct. Go ahead and try the next two on your own and check back to see if your answers are correct. Remember, your answer must be a coordinate to make it correct. All right, so these are the answers I got. Hopefully your lines are a little straighter than mine, but I have that in the first example, they cross at this point of negative 1, negative 1. And then this second one, the second example, they cross at 1, 0. So make sure your answers have the coordinate written correctly. And remember, you can plug in and check your answers to know that they're correct. Go ahead and do the next two examples again. You do have standard form this time, so you will have to either find your intercepts or move the equations into slope-intercept form. Graph the two, find the point where they cross, and then check back to see if your answer is correct. All right, so here are my answers that I got on these. Make sure that you graph the lines correctly. When I did change my equations into slope-intercept form, I wrote them. So make sure that you first changed your equations correctly, and then just double check that you counted correctly for the coordinate. So in green, that is your answer. Again, it has to be a coordinate when you do that.